Okay, so today's lesson is all about sketching any curve. Obviously, up to this point, at least in pre-calculus, we focused mainly on lines, parabolas, and the basic graphs. But this is focusing on these polynomials that have very high powers. Again, last year in pre-calculus, when we did these polynomials, if you remember, we basically figured out where the roots were and the intercepts, and we left it at that. But there is so much more to a graph. There's so much that can go on between those significant points that we have to make sure we understand how to do that. And that's what this entire chapter is really about, getting a handle on what do these polynomial functions actually look like when we look at their graphs. There's a lot of neat things that can happen to this. So today we're going to focus on that. I'm going to do 3 examples, and I'm hoping that when you come in, your notes will include all 3 examples. This is absolutely critical that we can do these super quick, because the CLEP exam will never ask a question that says graph this. They might say which of these graphs represents this function, but more than likely they're going to basically say, when is this function increasing? When is there a maximum? When is there a minimum? When is it decreasing? When is the relative minimums? When is the relative maximums? And all those other questions that I was asking yesterday in the class time that we worked together. So the first major step in sketching any curve, and that's obviously our goal today, is to first understand that what we need to know is to form a table, and we need to know what's going on the ends, all the way to the right and all the way to the left. So the way that we deal with that is by looking at infinity. So in our first example, and I'm going to try and go along with what you see here. So we have form a table, always include plus or minus infinity. So I'm going to do just that. I'm going to set up my table, and I'm going to put infinity and negative infinity. You'll notice I leave space in between, because when I set these up, I really like to have them in chronological order and allow for that, so that when we're graphing, we can actually group things together and connect the things that should be together. You'll see what I mean as we do this. So to evaluate infinity, really what we're saying is I want you to do the limit as x is approaching infinity. Obviously, we can't ever actually get to infinity. It's a concept more than it is an actual number. So when I say infinity cubed minus 6 times infinity plus 2, hopefully we quickly recognize we're going to take the highest power, and that would just simply be infinity. If we put negative infinity, similar action actually takes place, but this time when we put negative infinity into x cubed, it gives us back negative infinity. Okay, good. Now, the second step of this, that was hopefully the easy step, and that's the first one. The second one is we need to find the points of horizontal tangency. When does that happen? When do we find points of horizontal tangency? Maximum and minimums. Good. And what does that mean? It means when the slope is 0. So what we have to do is we have to now take this lovely equation, and we need to set it equal to 0. The equation itself, absolutely not. We need to know when the points of horizontal tangency occur. So we need to actually find its derivative. So what is the derivative here? Hopefully you were able to get 3x squared minus 12x, and we want to set that equal to 0. So now we're going to solve this. In order to solve this, this is going to require us to factor, and I can tell because why? Good, the squared. And what do we notice about this function? The 3 and the x are in common. Wonderful. And so I get x minus 4 equals 0. I solve. I get 3x equals 0, and so that means x equals 0. And I get x equals 4. So what that says to me is up here, I'm going to put 4 and I'm going to put 0. Now, eventually we will add other things into this. But for now, that's as far as we're going to take this, at least for today. We will be adding to that because there is definitely another piece that we want to include. So, okay, how do I find this y value that goes with 4? And how do I find the y value that goes with the x? Back into the equation. So what I'm going to do is plug 4 into my equation. So I have 4 cubed minus 6 times 4 squared plus 2. So that would mean 4 cubed is 64. And then I have 16 times 6, so it's minus 96 plus 2. So 64 minus 96 is 32, so I have a negative 32 plus 2, which gives me negative 30. So that means we're going to put negative 30 right in here. In the same way, we're going to plug 0 into the equation. So I would have 0 cubed minus 6 times 0 squared plus 2. Hopefully this didn't take you too long to figure out that that's 2. So when we're graphing, or rather sketching this curve, I want the point for negative 30. We'll call that negative 30 down here. I need 0, 2 labeled as well. And then I need to note what's happening on the ends. So what I want you to notice here is it's at 4, negative 30, and it's at 0, 2 that we have a slope or of 0 or a point of horizontal tangency. And just like we were practicing on our packets, what I want you to do is when you connect these, it's not a straight line, but rather a curve, and it's got to come in at 0. Now, as far as what happens on the right, if you notice it says infinity goes to infinity, that means that to the right it must come up. And then negative infinity goes to negative infinity, so that means the less thing, this thing goes on the left, is go down. Good. The next example we have here is x cubed plus 3x squared plus 1. If you want to go ahead and give it a shot on your own, please feel free, but I'm going to talk you through this one, and hopefully we'll get some explanations as we go through. All right, we're going to form our table, and we're going to start with infinity and negative infinity. Plugging in infinity into this equation, infinity cubed is infinity and negative infinity is negative infinity. So hopefully that's pretty clear. Now we want to find the points of horizontal tangency. And so how do I do that? Exactly, I want to find the derivative and I want to set that equal to 0. You'll notice this looks very similar to the question we just did, but there is a change. There is a different y-intercept, and so that will be a little interesting. And this also does have a root of negative 4 instead of positive 4. So I'm going to put 0 first and then negative 4. Again, notice I'm paying attention to what order it should go in, because these two here, the 0 and the infinity, group together, and negative 4 and negative infinity, they will group together. It just works out very nicely, at least. Okay, so let's go ahead and plug 0 into the equation. We get 0, 1. And I plug negative 4 into the equation. And similarly, actually, but let's just do that. Negative 4 cubed plus 3 times negative 4 squared plus 1. So negative 4 cubed, again, that is 64, and that's going to be negative 64. We have 16 times 3 this time there, so that's 48. So it's a positive 48 plus 1. So negative 64 plus 1. So that's negative 16 plus 1, giving me negative 15. Okay. Again, we quickly do our little graph here, negative 4, negative 15. I've got 0, 1. And again, when I connect between the two, I want to come in slowly. Negative infinity goes again to negative infinity, and positive infinity goes up. It looks a little different, doesn't it now? Great. Last example, and you'll notice this is x squared graph, so obviously we've learned other ways to graph these parabolas, but I want to show you even a more basic graph that you should obviously know how to do a different way, but using the same technique. You'll see how very much the same they turn out. All right, infinity, we plug infinity squared, that'd be infinity, and negative infinity squared would be infinity again. Then I want to, again, do points of horizontal tangency. So that would mean my derivative, 2x minus 6, and I'm going to set that equal to 0. So I have 2x equals 6, so x equals 3. And so 3, what would that represent? Another thought for you to think about. What is another name for that 3, whatever the y value is? What is another title for that? So when we plug 3 in here, we get 3 squared minus 6 times 3 plus 8. So I have 9 minus 18, or negative 9 plus 8, so I get negative 1. 3, negative 1. And then I know it goes to infinity on both sides, right? And so technically, if I wanted to be really picky, we should indicate that intercept so you can see where that goes. But for right now, we're just really going to focus on the infinities and the slopes equal to 0, or the horizontal tangency. Okay, hopefully those examples were sufficient for you to see those two steps in action. And we will be adding to this, so please make sure you make a note of that and leave some space in your notes as we add more steps.